Can you believe this? The things I have to put up with on this particular live stream. I can't believe this. I'm here to talk to you about Azure Fundamentals. Fundamental stuff about Azure and the Azure platform. It's going to be good. You going to join me or what? I think we're there. Azure Fundamentals, really, when I submitted this talk, what I was going to be talking about was actually a server hugger's perspective to what's new and cool inside of Azure IaaS. But they wouldn't let me use that title, so I decided to put that as my second title slide so they wouldn't notice it. And then I can go ahead and just use it anyway. But as I'm sure you've heard from the last couple of days, there's been a huge amount of change going on in the world of IT, the world of Microsoft. The session coming up after me is going to be really exciting and talking about Azure Stack and what's going on with that. I saw Woolsey earlier today going on talking about Server 2016 with on-premises technologies. I'm coming from the on-premises world, transitioned over to the Azure cloud environment, and now I actually work for the Azure compute team. The guys responsible and the gals responsible for Azure IaaS, among other things. But Azure IaaS kind of holds a place near and dear to my heart. So some of the stats, and the funny thing is that this particular slide, if you've seen it today, even if you saw it earlier today, the numbers have changed already because we're working on such a massive, different, and large scale than what we've had before. And so you've got things that are able to say and look at the number of millions upon millions of cores that we have running inside of our data centers, the number of different types of workloads that are out there, 77 different trillion objects in storage. I'm almost guaranteed that that number is out of date if I talk to my storage guys over in the Azure side of things. The one thing that actually caught my attention was interesting, being the Microsoft guy, that if you cut me, I bleed blue, Microsoft blue, is that 1 out of 4 VMs, 25% of the VMs that are running inside of Azure right now are actually Linux machines that are out there. And so we've built this platform from a scalability perspective to treat any operating system as a first-class citizen so that you can choose what you want to use inside of the cloud environment, be it Windows, be it Linux, be it some variation thereof, and that sort of stuff. And so I made the switch over to the Azure Compute team a little while ago, and these numbers, as I mentioned, are almost up to date. But I still get asked a lot of questions because I'm known as the server guy that's out there about what's going on, why did you move, should I be concerned about this, what can I do to get started, all that sort of stuff. And so this particular session is going to cover off the basics that you need to know, as well as answering questions as well. I'm hoping I'm going to get some questions on the moderated teleprompter as we go. So whoever's looking after that somewhere inside the social room, just let me know that you can fire me some questions up on the teleprompter, and I'll take them as we go. Hopefully I'll even be able to show you some demos near the end for what's going on, but we got a lot of material to cover, so let's actually just go ahead and dive in there. Now, this is a slide you see an awful lot of with regards to how we think about our cloud platform and how we like to try to explain it. And this is something that I use as well from a discussion perspective when I talk to customers, when I talk to IT professionals that are out in the workforce, talking about the Azure and how this is and how this works. And really it comes down to a lot of the concerns that they might have or things that they've heard over the last little while. So it comes down to things like, in this case, we'll talk at the very top of the pyramid, talking about things called hyperscale, with the concept of just sheer scale and size of what's out there. This has changed over the years, and so I thought I'd kind of give you some representations of what this looked like from a map perspective, and also some physical representations as well, because I'm used to working in data centers that maybe occupy a business floor of a building, of a high-rise, or maybe anything from as small as a server closet or underneath someone's desk, to now we're working inside these massive data centers. That's my own personal experience. Example was when we came out in 2013 with this environment for Azure IaaS, we had a number of areas that were available, 2, 4, 6, 8, 10, about 10, 11, 12 or so. 2014 we grew and expanded those besides east-west parallels in different continents, but also some north-south capabilities as well. We added in China, we added in Asia Pacific with Australia in there, Brazil also was added in, and we've even gone ahead and made some announcements with regards to some other ones that are on the way too, which include different data centers in India, a couple of pair of data centers up in Quebec City, as well as Toronto, back there in northern Canada, up inside above the 49th parallel. Also stuff going on in England, stuff going on in Germany. We've made all these public announcements about this because we're trying to be flexible, meet our customers' needs, and make sure that we've got coverage where you're looking to deploy your apps inside of the cloud, no matter where you happen to be. So I think we're up to like 22, 24-ish that are actually up and running, and then more announced as well. So more are coming soon as they speak. But one of those little dots, let's actually go and try to break into a little bit about what one of those little dots actually means. The smallest footprint that we have is actually just a single pair of jumbo jets on top of a individual soccer field, a football pitch if you're from Europe, soccer pitch if you are from North America. And actually, in some areas, we actually get upwards of 600,000 plus servers inside of some individual regions. Each one of those regions was one of those little dots inside of that environment. They may not be directly inside the same building. A region can be a little bit larger than that. But then I'm like, how can I go even better at being able to explain this? And so I actually managed to get approval to show you this picture. This is one of our data centers out east, in the United States. That little tiny thing that was just circled in the bottom left-hand corner is actually a full 18-wheeler semi-transport truck. If you're from the UK, that's a lorry, I guess it is. It's not a ute. A ute's too small. That's a lorry. A big 18-wheel lorry. That's the old part of the data center. It's at the front. Slightly newer part of the data center that's just off to the left of that. What's more interesting, if you look at the back of that particular photo, you can just see the edge of some new stuff breaking ground. And then more importantly, if you switch angles, excuse me, this is the 5 square miles of additional space that we've cleared out to be able to go into prep to pour the cement, to be able to get more stuff built in. That's just the scope of just how large of investment that we're making on a physical scale for one of our regions, and we're growing them as capacity requires and as customer demand is there to be able to meet your needs, to be able to handle where things are. Not every region is the same, different environments, different configurations, but I just thought I'd use that as like a real kind of grab yourself and understand what's going on, shaking your head and understand the size and scope of what it is we're talking about with provisioning. When you have just a web portal interface or a PowerShell command prompt up and talking to Azure and working with your subscription, kind of think about where you're actually provisioning these different systems inside these different regions to kind of see where stuff is at. It's a good way to kind of get a reality check for where things are. That's about scale. If you aren't playing on this level of scale in the public cloud environment, you're going to be left behind because it takes a lot of infrastructure, a lot of time to be able to build these different things, and people are playing catch-up or trying to play catch-up. So that's just one example from a scale perspective. Hang on a second, because I am recovering from a cold, so let me see me grab a little drink of water here. Sorry, not water. This is a caffeinated drink, I am told. So the next thing that comes up really when it talks about scale and about things and discussions around Azure, people always come up and ask me about, okay, so Azure, deploying resources, how this all works. I'm used to working in an on-premises environment. I'm used to working with virtualization technologies. I'm used to working with Hyper-V, with VMware, with System Center, with KMS, whatever your virtualization solutions happens to be. What can I do and how does this work and how can I make these two different systems work? And so you don't have to jump and put everything inside the cloud immediately. We're absolutely not recommending you go off and do that. If you're interested, spend the time, learn what's going on, understand how to put stuff into the cloud, understand how you can go off and use stuff. But we're actually condoning and recommending people go off and start using a hybrid approach if that makes the most sense. Maybe you can start a net new project inside the cloud environment. Absolutely, we'll support that fully. Maybe you want to keep some stuff on premises because you're more comfortable with it being on premises. Absolutely, you're more than welcome to. We have a really solid hybrid story for how you can go off and get together with this. The good part is this also works on a small scale environment. If you're just doing like an MSDN subscription and you're trying things out, you just got yourself a trial up and working as well. All those different scenarios happen to work for this. The first way you can obviously have some kind of hybrid connectivity with Azure is going to be the simplest form, just even like a point-to-site VPN connection. So from your dev box, from your Hyper-V lab machine, if you have one machine that you got Hyper-V on as an example, you can actually make a P2S point-to-site connection over an SSL 443 connection up into the Azure environment. You're going to make this into a VPN gateway that you've created, and then you're going to connect up to it for a point-to-site connection, and then you now have whatever resources are on that local box able to talk to your resources up inside the Azure environment, inside that VNet. Really, you're probably going to want to set up something like this, which is a VPN connection for a site-to-site connection, which can be done as small and as simple as going through and using RRAS on top of a Server 2012 or 2012 R2 box. It can also be a physical box like a PIX or a Cisco device. We've got a bunch of list of different systems that are up there. We even give you configuration scripts that you can use to be able to make sure you've got these things configured correctly. This will give you full routable capability into a VNet or multiple VNets that are out there that are on the system. This is better for like a dev environment. You're going to have multiple machines. You're going to want to try to simulate your environment, see how it is before you actually jump in with the big investment to have what we call an express route connection. Express route is basically our option for being able to have a leased line or dedicated line, an MPLS connection, over from one of our partners that we have growing and growing continuously around the world, directly into one of your VNets. You can even have an express route connection that has a fallback over onto a site-to-site connection if you wanted to. And so these are basically high-speed connections, literally to your carrier. Your carrier, just like you would have set up a branch office to one of your other sites, you simply set that up to have it go to one of our data centers that's in the partner environment, and you have a connection into that environment with a range of speed and a range of bandwidth you're allowed to have through that type of connection. Literally, you handle name resolution if you want to, you handle connectivity, and you've got, just like it is like another routable subnet off of that particular connection into your environment. So lots of connectivity options that we definitely promote and are fully supported inside of your Azure subscriptions. Now, obviously, I don't recommend you go off and use an express route connection for your MSDN connection, but, you know, if you want to, you can. It's your call. It depends if you have a good agreement with your service provider for a good price. Now we come up into the next third level of discussion. I think this slide is supposed to mean something about scale and security. I don't know why I get that idea, but someone else made this particular slide, and I guess they're trying to be funny with a scale and a lock as far as security is concerned. And so, yes, we are absolutely 100% enterprise grade for the stuff that we do. We have a number of attestations, a number of certifications, a number of different levels of checks and safeguards are in place that meet all sorts of different international and national requirements for government agencies, for private agencies, for HIPAA, for all sorts of different levels of stuff. And then we have a whole team of people around the world whose job it is to make sure that we maintain these. I talk about this from a perspective of an IT pro talking to an IT pro with, you know, how does this work? So from a trust and control perspective, because ultimately when you're talking about a public cloud provider, you have to trust this public cloud provider is going to give you what you need to be able to provide you with a secure area to spin up your configuration of infrastructure, spin up your machines and run your application and give you the best value for what you need to have. So from a trust and control perspective, if you remember that picture, around the perimeter of those data centers is actually a very large fence. And that very large fence is actually patrolled by a security force. And they do not just allow anyone to walk up and go into that particular environment. You actually have to have a reason for being there. And you can't just magically show up in your Jeep and decide you can drive in like I was going to try one day. I was told not to because apparently they would turn you away. So, absolutely, physical protection is there as far as controls and alarms, cameras, 24-hour security staff. You have to have a reason for being there. It's a big, long process. You also have two-factor access control in and out of different areas inside the buildings. And you also have multiple days of backup power from multiple sources into our data centers. So from a physical perspective, we kind of have you covered for almost all the different angles that you need to worry about from a physical perspective. Incidentally, this brings up a good point. If you have an existing relationship with a Microsoft account environment, with a Premier Support contract, or with other types of engagements within Microsoft, potentially you can actually request access to take a tour of one of our sample areas inside of a data center. And so I suggest you actually check that out. I'm still waiting for approval to go on one of these things. I don't know why they're delaying it for me, but apparently you can actually go and get a tour of the individual areas, and I'm told it's actually quite interesting. Now, inside the data center, the way we run our fabric and our infrastructure is basically built from the ground up to do infrastructure as a service and platform as a service as we've evolved over the years, with the idea of having operational security controls in place from the very, very beginning. We also, as I mentioned, have a whole team of people that are responsible to ensure that we maintain all of our compliance and certifications at all the time. And then obviously we have a whole bunch of stuff that goes on in the background to make sure that we have checks and balances and monitoring that takes place on the traffic coming into our data centers to make sure that no one is trying to penetrate or do anything to our customers inside those different data centers. So we have our infrastructure cover that's in there. Even further into that little onion peel of different levels is our network area, where each of our individual subscriptions are basically our security boundary for stuff. We also have individual subnets and VNets inside of those subscriptions and different projects. We've got access control lists on each one of those different levels of subnets and also machines. We also have role-based access control that you can put on top of your machines to give you different levels of granularity of control. We also have security infrastructure you can decide to use, like key vault servers and KMS management to be able to look after your different keys. And obviously, multiple NICs and multiple different levels of parameters you can have for your infrastructure that you have designed inside of your solution. And then finally, at the lowest level, in the VM level themselves, we obviously have the ability to run VM anti-malware in there if you wanted to. We have security extensions available for you to use. We have security monitoring system that we just actually announced just recently at the RSA conference that you can go off and take a look at with Azure Security Center. Very, very cool stuff on Azure Security Center. Logging and auditing, key vault and encryption, all that sort of stuff. We've got you covered with the different trust and control levels. I think I've kind of talked to this point quite a lot because people always ask me these questions about what can you offer up from a security perspective inside of these Azure data centers and inside this Azure environment. So once you've understood and you've gotten the concepts of this pure scale of what we're talking about with 24, 28 different regions that are going to be available in the near future, with the sheer size of these data centers that are in there, and then the fact that you literally just have to go to the portal website, sign up for a trial, log in and authenticate, and then start to work and to use the Azure environment and provision the machine. That's the kind of scope and size and scale that we're talking about for these different regions. Then I like to break down and kind of demystify this whole thing with regards to IaaS, so infrastructure as a service. I'm not going to be talking about PaaS, platform as a service, and all the different pieces that are in there as far as PaaS is concerned, because you need to be aware of what that is. That's ultimately where you want to go, but as an IT pro, you're going to probably get your feet wet and start working on this lift and shift concept of moving pieces of your infrastructure up inside of the Azure environment, keeping a hybrid environment, or maybe just simply lift and shift everything up into the Azure environment. You choose what makes the most sense for you. You have to really understand how this whole infrastructure works to be able to properly design and leverage this. And so I can't tell you the number of times that I've been called into a whiteboarding discussion or a coaching discussion, talking with different customers about how IaaS is working. After the fact, when they've tried to go off and do a deploy, just thinking they could just go and copy and paste, if you will, from on-premises up into the Azure environment, it does require some architecture discussions for how things work. So I like to break this down kind of in the following ways. The first part is storage. Like any virtualization platform, you got to worry about storage, compute, and networking. So I talk about storage first with what we do inside the storage environment. So at Azure Virtual Machine, basically we have a bunch of different architectures of families that we have that you can deploy when you say new compute virtual machine, size of machine that you want to go off and deploy. The size of machine is going to be a series, either an A series, a D series, a G series, possibly an N series. It's coming up as well. But basically, the A series and the D series are what I like to call running on top of spinning rust, otherwise known as platters that are out there. Actually, the A drive is the only one that's running on top of a spinning platter. The D, DS, G, GS, and other ones, they're actually been upgraded now, working with all with SSDs. And so the idea is that you got a virtual machine that's running. The C drive is on the local disk of that particular virtual machine. It's been copied down and brought down. And then you have a cache that goes off and talks to the Azure blob environment for what's there. You're able to go ahead and to attach different disks to be able to have your data preserved over time and survive a restart or a movement of that machine inside of the Azure infrastructure. So when you do a deploy, the C drive and the D drive get deployed for you. The D drive is purely temporary. It's all that you use it for is for temporary information, because when you get redeployed, you have no idea if that D drive is going to be the same D drive that you were there before, because it gets dissolved, if you will, inside of the provision environment. E, F, G, H, I, J, and the rest of them basically are additional disks that you attach. Those disks can then be ganged together inside of array configuration or inside of a storage spaces configuration, if we're talking Windows, to give you the best performance and have a durable disk that survives of a restart of a system. So that's the basic architecture of how our machines are actually deployed inside of an Azure environment. This gets copied down to a blade, a resource that's running off the top of that blade, and then talking to those different infrastructure that's out there. Now this storage that's talking to, I think you heard Woolsey talk about this earlier on with durable storage, with software-defined networking, software-defined storage, and software-defined compute. And so software-defined storage, basically, we are abstracting the actual area that you're writing to as far as an OS is concerned. We give it a drive, but it's actually backed by our storage infrastructure inside of the Azure environment. And inside that storage infrastructure, we're basically writing to what's known as a page blob. And we have 3 different copies of that page blob at any given time across different parts of our infrastructure inside the same data center that's out there. You can choose, for those particular page blobs, for 3 different copies, they can go up to about 1 terabyte in size of disk. You're limited with spinning drives, the standard storage, 500 IOPS per drive that you attach. You can get more IOPS by having more drives together. But those copies are basically preserved in case one storage cluster happens to go down. There is a copy of that data on another area, and basically in the background, you don't have to worry about that system. You're good to go. The data is still there. Now, an interesting thing, as I mentioned, we write it across 3 different ways when it's all there. An interesting thing is that we actually gave you the ability, if you wanted to go ahead and to replicate that against a regional disaster by replicating the data to another data center. And we have recommended pairs that we can replicate to. So West Coast United States to East Coast United States, North in the United States to South United States. Keep it inside the country as an example if you wanted to, in between Europe and Northern Europe or any of our other areas that we happen to have up and running. So we always try to pair these things, and they're at least 400 miles, greater than 400 miles away apart from each other to basically look after the case in some kind of geographical disaster that's going to happen inside of one area. Now, this other copy that's out there, just so you know, isn't available for use simultaneously. That's as a system. It is available for basically preserving your data, and then if you need to, you can bring your stuff up in that other area. There is a way you can even enable it for read-only access, but that's more of an advanced topic we can talk about and something that the database admins are going to want to be aware of. So we're even defended against regional disasters. Storage, basically, I'll talk about in a second more when I talk about the compute environment. This is the part that I like. This is the stuff I can see, feel, and touch almost inside of my own server room. I can now do the same thing inside of the Azure environment. So you've probably heard the families. I've mentioned the families before. So here's my family picture here. I've got the A's, the D's, and the G's that came out. We started off with the A's. Those A's are basically very, very cheap and efficient systems that you can use, and you can provision if you wanted to. They're basically the oldest generation of hardware that we happen to have. They're the cheapest cost to be able to use, but they're great for a dev test environment, great for just trying things out, great to make your trial last a long time. Next up is basically the Ds. The Ds are a newer generation of hardware that have SSDs as far as our temporary drives are concerned, much faster CPUs than the A's were, and they basically are almost our current level of the most advanced stuff that we happen to have inside of our data centers. And I'll say almost for a reason in just a minute. The Gs are basically one thing that we announced a while ago. It's been over a year now. But the Gs are basically the largest virtual machine you can still buy to this date inside the public cloud based on who you slice and dice the market information from. But picture a G5 with 32 cores, 448 gigs of RAM, 7 terabytes of local storage, and up to 64 disks being attached to this monster device. So you've got some serious horsepower inside of these boxes as far as a G is concerned. And then I mentioned this thing called premium storage that we came out with just over a year ago. Premium storage, remember how I mentioned storage-wise, you can have durable disks when you attach drives into your virtual machines, be they Linux or Windows. You then are able to make a RAID pack or a storage space out of that to be able to get better performance. Well, you can choose to provision these disks using standard storage for 500 IOPS or premium storage for, when you gang them together, greater than 80,000 IOPS of possible storage if you wanted to. So performance-wise, we've got you covered. Now, I mentioned that we have another version of hardware that's out there. The DV2 is rapidly being available across all the different areas. You'll know that it's available inside of your data center when you actually go through and try to provision. You choose all options when you're provisioning for your size of machines, and you might see DV2s. DV2s are 35% faster than the previous generation Ds, which were 50% faster than the previous generation of As. So again, latest cutting-edge hardware that's out there. These are running Intel's version 3 CPU family, Intel Generation 5s. Very, very fast systems. DV2 is my go-to box for production. Starting off, way to go. There's only a slight incremental difference in cost over the Ds that are out there. So be aware of the DV2s that are available for use. And we announced at AzureCon a while ago a partnership with NVIDIA to be able to make the Ns. These Ns are GPU accelerated and enabled virtual machines. These N systems, these N series boxes, actually have the NVIDIA GPU inside of them. You can do remote virtualization. You can do compute intensive stuff for data analysis. You can even do video editing, video streaming, that sort of stuff off of them as well, because these are CUDA enabled GPUs. And you can, again, use them inside your solution if you wanted to. The best part about all these different boxes that I'm talking about right now Any one of them you can provision your operating system to, it will be supported. If it's a Linux OS, if it's running Ubuntu, if it's running Red Hat, if it's running Windows, if it's running Windows 2012 and 2012 R2, even the pre-release versions of 2016, all the drivers are there. They're all optimized. They're all ready to go to take advantage of all the different pieces that are in there. Now, the ends are not available as of yet. They're finishing off our certification, finishing off our testing, that sort of stuff, before they get inserted into a select few of our data centers and eventually rolled out where demand is required. And so hang in there. Ends are going to be available in the not too distant future, but they're not currently available right now. Now, I mentioned I was a hardware geek. Let me just grab another drink of this caffeinated juice here. I mentioned I was a hardware geek, and so I wanted to bring back this G family. I love the fact that we have this G family. Despite popular belief, this is not named after Golnaz, the producer here at Channel 9, just by the pure awesomeness that she has, just like the pure awesomeness of this G family. The G family basically is optimized for massive data workloads, massive amounts of RAM. So I mentioned 448 gigs of RAM, 6.5 terabytes of local SSD, latest Intel processor, 64 attached disks. So I said, if I went and provisioned this and I left it running 24 hours a day, 7 days a week, what would it cost me for a single month to run this individual box? Well, worked out the math without the disks attached. I think it's somewhere to the tune of, let's say, rounding it up, carry the 1 and the 2. It's probably around $6,500 to $7,000 for the entire month if you ran 24/7. The great thing about this is, with any of these machines that we're talking about right now, you're only paying for the minutes that you actually leave things running. So if you don't need to leave this thing running all the time, don't leave it running. I unfortunately had a demonstration that I had at one of my conferences not too long ago where I did leave this running, and I knew that I left it running because of the bill that I got. So please try this out, but you can provision this probably in under 5 minutes and have it up and running. The reason why I call that out is because of this. I decided to go ahead and pull up a little friendly information. Take a look at the slide there. For regards to what it would cost if you were actually going to go off and try to buy one of these systems off of your hardware vendor of choice to see what it would cost to be able to run one of these different systems. So I spec'd out the same amount of CPUs, the same amount of RAM, the same amount of drive configuration for the most part. And if you can see here, it actually comes out to, before discounts, around $66,000. Or if I bring this up in larger, so you can actually see it here, $66,000. But look at the ship time. 11 to 15 days before it even leaves their environment and shows up inside of your inside of your shop. I could have deployed one of these G machines when I started talking about the G family. It would already be done with an operating system on it inside of my solution and up and running right now that I could have a remote console into faster than what we can do by ordering this physical box from one of our partners. And so, interesting. I haven't had to buy one of these boxes in a while, but it's a good comparison for the flexibility that you get inside of your environment for being able to deploy these big compute workloads, should you need them inside of your environment. So I mentioned compute, storage, and networking. Networking is the last part. I want to mention a couple of things with regards to networking. Basically, the big fat pipe you have to worry about to your boxes, from your boxes to your customers, and also between the boxes as well for what's in there. The biggest change that we have really is the from and in between your boxes that are inside of the Azure environment with changes that we've been making recently. So one of the things that came up is the ability to have granular access control lists that happen between different tiers. And so as I define my infrastructure, and I say I've got front-end boxes, I've got my logic boxes, I've got my back-end database boxes that are out there. In a typical environment that's actually inside of a data center, I would define who can talk to what box, what ports they can talk on, and everything else along those lines. Well, we have the ability for you to do that right now. One of the ways you can do some restrictions on it, at the simplest level, is just having some access control lists or some ACLs between the different subnets. But we've actually taken another step even further, where you're able to go in and create these things that we call NSGs, or network security groups. Network security groups goes down to the level of you defining which box over which port can talk to which other box inside of your environment. And all that applies also to go off and talk to your on-premises environment as well. So you have total granular capabilities to look after these boxes, how they talk to each other, the exact same way you would do it inside of your own environment, and you don't have to go to some service provider's web page, make the change request, wait for the person to wake up and see that, and then go ahead and do it. You do it all through either the portal or through command line PowerShell stuff, or through the definition of your infrastructure with your infrastructure as code JSON file, which I'll talk about just a little bit later on. And so definitely very good stuff that's in there from a networking perspective. Some of the machines have access to some systems that are based out of, some of the systems have things that are based out of your normal way of working inside of your data center environment. They definitely still apply inside of your environment, inside the Azure world. So then I kind of talk about some things that you need to kind of pay attention to. You've got the basics. You understand anyone can go to azure.com. Anyone can go and sign up for your trial environment. You can use your resources to be able to learn about how this thing works. You can use the skills you already have to be able to go off and work with these different machines. But some things that I really want to call to your attention. Probably the first one, which I'm hoping you probably heard from Mr. Woolsey in the morning, is his concept of the Azure Resource Manager, or ARM as we call it. This is basically our ability for you to choose the tool that you want inside of your environments to be able to manipulate your subscription and what you want to do to that subscription to be able to build your solution. And that can be an equivalent or a parallel to what someone would call infrastructure as code. I can define all the rules, all the machines, all the deployment mechanisms, all the scales and everything else inside of my definition file. We call a JSON file for an ARM template. And then I can go ahead and deploy it. And I can use whatever tools I want to do that deployment. You can see at the top there, I can deploy it from the portal with an Azure cloud. I can do it from the command line using PowerShell if I wanted to. I could even do it directly inside of Visual Studio if I had Visual Studio installed on my box. I can do that too. That goes and talks to the Service Management API, which then talks to the Resource Manager, which can deploy stuff to the cloud environment, and with the advent of the Azure Stack, could also possibly deploy stuff to your on-premises environment. But I'll save that for the next session. And it obviously can look to and understand things with what's going on with your Azure Active Directory from a security principles perspective. And then finally, go down and talk to those different resource providers. Spin me up a machine, spin me up a network, spin me up some storage, configure my database, that sort of stuff. That's where it goes and talks to those resource providers that are out there. And on top of all this, I always get this discussion base that comes up after this, which is, hey, if I'm going to be doing this, am I have to now stop learning PowerShell and start understanding how ARM works? Well, do both things. Don't just stop learning PowerShell, because obviously that's, if you haven't already, something you definitely should do. You're able to go and kick off an automated process during your deployment and after your deployment where you basically can inject some scripts into your boxes, like PowerShell scripts. You can invest and do some automation inside your subscription with Azure Automation, which uses PowerShell if you wanted to. Or if you're from the Linux world, you can also use obviously your bash scripts if you wanted to still configure using those. Or you can even use some of our third-party extensions that are out there. So if you're comfortable using Chef and different Chef recipes to configure your box, you're more than welcome to. Doing some Puppet Lab configurations, or even throwing your own solution on top of your own platform as a service with Cloud Foundry. Your choice for how you want to do this. So if I step back from the marketing piece about this and think about Azure Resource Manager, what does ARM or Azure Resource Manager actually do for me? And this is something you definitely want to pay attention to, understand how ARM works. When you're using Azure Resource Manager, you're basically able to group all of the different resources and resource providers together inside of one area. Think of it like a container, if you will, where everything all applies to that one individual resource group. You can choose to have multiple resource groups talking to each other, or have all of them consolidated inside of one resource group if you wanted to. That resource group lives within inside of your data center region you've deployed to. You can manage those resources as a single unit. What does that mean? That means you can delegate control to say, hey, Matt McSpirit, he's relatively new to Azure. I'm only going to really give him access to look after some of the virtual machines and nothing else. I don't want him to look at any of the networks or network configurations. Leave that for the networking guy. Matt can go ahead and work with and talk to individual machines. I can apply an RBAC role for what's going on, where only Matt's user ID inside of Active Directory can actually go and talk to that individual machine and work with that machine. Same thing applies for tables and databases and other different pieces within there. Neat thing about Azure Resource Groups as well, from an IT Pro perspective, you can tag the resource group and you can tag the resources inside of those resource groups so that they show up differently on your bill. So you can actually get a broken down bill for what all the different costs are, because all this stuff is on-demand billing. You need to be able to figure out who's doing what inside your environment. You can keep controls and tabs on that by having different tags associated with your different resources. So Azure Resource Manager templates is one way we can go off and get started on some of this sort of stuff, or for the ARM templates. Now, an ARM template is something that is basically a text file that is stored inside of a JSON format that allows you to basically go through and simplify your deployment, simplify your rollback. It's really the embodiment of one way of doing infrastructure as code, if you will, where you define every single role of every single resource, their configuration, their sizes, their deployment methodology, how they all work, and then you can literally check that into source control if you wanted to. Or you can keep it on your local box if you want to stay old school, if you want to go that route too. They really are just some text files that has a bunch of variables and stuff that are in there that allows you to define dependencies in architecture. So in this example here, an ARM template that's going to be working with a database and also working with a front end and a back end and also individual virtual machines. You can define all those different components inside of this ARM template. Version it, make changes to it, lock it in place if you want to with source control. When your devs are deploying their project, they're going to use this template. You know it's configured correctly, and it literally becomes infrastructure as code. You can check in. Neat thing about this is it also allows you to have a level of dependencies. Instead of having stuff serially applied and serially deployed, you now can deploy in parallel, but you can also go in and put depends and dependencies in place to say, you know what? For this particular environment, let's say this happens to be a SQL highly available cluster. Well, for a SQL highly available cluster, you have to have Active Directory up and working. So deploy the VMs for AD first, and do 2 of them because you want to have some redundancy in there. When they're up and running, then go ahead and deploy your SQL. Wait for the first SQL to be finished before you deploy your second SQL. But you know what? You can go ahead and deploy some of those basic web servers in the background while you're waiting for this to happen. Once the SQL happens to be finished, then go ahead and configure the cluster pieces of this as well. So all this can be contained inside of your individual's environment for a JSON template. Now, this is something that we've been out with now for a while. We announced it at Ignite Chicago a while ago. It's been almost a year now, wow, for the way this works for ARM environments. And so we've been trying to grow this community of how these things work and the documentation around this sort of stuff as fast as we can. But the main improvements that you should be paying attention to with ARM and with virtual machines is basically you now no longer have this time-delayed serial deployment, even though, yes, if anyone wants to split hairs, that was a serial deployment of all those machines because they were one after the other. Pretend it happened simultaneously. But basically you can have parallel deployment of your resources for scale of individual virtual machines. The other thing that we've made available with ARM environment, with the Azure Resource Manager environment, is the fact that you now are able to define multiple fault domains inside of your environment. What this means is a fault domain is going to make it so that when we have an issue, we're going to move virtual machines, when you deploy, across different power sources, across different racks, so that if one particular rack goes down or one power supply goes down, that particular fault domain is only going to be affected for the resources inside that one fault domain. Because you deployed 3 machines, the other 2 machines are perfectly fine and still continuing to run until that first machine comes back up again. We also have update domains, and update domains is where we do maintenance on the host. We will guarantee you that we'll keep the machines separate in those update domains and sprinkled across them so that when we do an update on the underlying fabric, we're only going to take down one of those update domains, do the update, and bring that guy back up again before we move on to the next one when it comes time for scheduled maintenance. So 3 fault domains, 3, and then 5 update domains. We also obviously have custom script extensions for different virtual machines. We've got some good information there as an example from a template perspective for where you can take a look at the different frameworks that we have. You can go off and try, and even go off and try how this works. So I understand it's a bit daunting to take a look at this new format of how you can define your infrastructure. It's taken me a while to get my head wrapped around how this works. And I know that Matt is still trying to get his head wrapped around how ARM templates work and how JSON files works, because it is a bit of a jump. It does look an awful lot like code, but it really is not that difficult once you understand the basic premise of how this works. So I thought I'd kind of break down and show you a JSON file as one example from what we have and what we call our quick starts library. So JSON files, they are simpler than they look. Basically, you've got a schema version that applies to that particular version of the JSON file. You then have the individual version of that particular file itself in case of any changes to it. And then you basically have parameters, variables, resources, and outputs for different sections. And so if I go and take a look at this, here is an example. The schema for this particular one is going to go ahead and use the schema version 1.0 for this particular sections of references that are inside of here. I then have parameters that are going to be available to me inside of my environment. These parameters are going to be filled in for, or I need to basically be prompted to fill these in inside of my user interface if I decide to throw this onto a PowerShell deployment or a web portal deployment. They're going to ask me and prompt me for these particular answers. So in this case, it's asking me for the storage account name, it's asking me for the admin user ID and the admin password as an example. Now, one word of caution, a lot of these quick start templates, the descriptions are varied in usefulness based on the author that created them. You're at the mercy of the author that created them. So sometimes you're going to get those really well-designed quick start templates that have some really good examples you can use for what should be in there. Sometimes they're going to be cryptic, and there's nothing we can do about that except make them better. And so the quick start templates are a good place to start. So parameters is your first place to understand how this kind of stuff works. Next up off of that is variables. Now variables basically are, if you don't want to have parameters filled in, you could hard code those individual parameters to be variables, and the variables get called later on when we're starting to talk about resources. And here you can see some plain readable stuff that kind of makes sense for the most part if you've ever worked in infrastructure before. So if I've got here, I've got, there we see, bring over the slides, switch over the slides for a second over there. So, here's the data center I want to go off and deploy to. I'm making a Windows Server image as part of my deployment. I'm going to be using an OS disk as a very simple OS disk name. I'm going to name it. My NIC is going to be named this. I'm going to be using as a addressing range of the 10.0.0.0 address range. I'm going to have a subnet that's going to be subnetted as a C-class subnet with a 24-bit mask. You can see here that I've got a name for the public side of the IP. I've got a VHD storage container that needs to be created. That's the name of it. I've got the name of my virtual machine, the size of the machine that's being created as well as a standard A2. This is almost interesting stuff that you can read and understand as plain English if you were to define what it would look like to make a virtual machine, because it is. You're defining these variables. We then call them inside the actual resource providers a little bit further down. As you can see under resources, you can see here, I'm going to go ahead, this chunk of JSON file goes ahead and provisions a storage account inside of my environment. And notice that it references a particular preview version of the API call. This is all stuff that's inside the stock templates that you don't need to change. I'm just showing it to you here for your own reference. And then over here is the network provider being called. You can see some of the variables are being used, so the location for where I want to have this guy deployed. Same thing for the virtual machine as well, because they both have to be inside the same region, and things like that. So if you take the time to read through some of the JSON files, you'll see that it makes mostly clear as mud sense when you actually break them down. And then here's an example as well of a parameter that can be filled in with some different values. And so I actually will give you a drop-down box if you wanted to go ahead and fill these guys in to say, what options do I have for deploying a Windows server? Well, in this case, for this example, I'm going to give you the choice of doing 2008 R2 SP1, 2012 data center, 2012 R2 data center as multiple different types of choices. Now, JSON files, if I go here, I'm just going to jump out of this. And I wanted to show you, of course I love it when PowerPoint does that, so I need to switch over to a duplicate mode. There we go. This is the Azure.com website. Nothing too crazy here to be able to see. I want to draw your attention to very basically where I'm actually looking at some of these resources. So the very first resource I want to show you today was basically those quick start templates. Under resources, under templates, basically this is where you're going to be able to go off and find those individual templates. Let me go off and make this a little bit larger so you can see it. And I was showing you one that was a very simple Windows virtual machine to do a search, type it in, and then down below you've got a bunch of different options for different types of quick start templates you can use. And you can see here some very simple templates that are out there. Sort by date added. I can go off over here. A good friend of mine is a big Minecraft nut. It looks like they actually don't have those ones anymore for where they were, but there are some Minecraft out there. If I spell Minecraft right, it would help. There we go. Now we try that again. There we go. I wanted to show you this particular one just because, as an example, to walk through what's going to be going on. So in this case, they're talking about the parameters that are going to be called up and inside that JSON file. In this case, it's a username for the individual user for your Mojang account or your Minecraft account, the admin username and password. In this case, because this is going to actually build a server, it's asking you for different things like difficulty, game mode you want to play, all sort of stuff you'd expect to see. And then they even give you the command line version for how you would deploy this individual deployment using PowerShell. In this case, it's using Resource Manager to go off and deploy and go off and have access to it. I want to actually show you what this template looks like. So if I click on that tab right there, it takes me over to GitHub. And it will actually show you what that JSON file looks like. If I zoom in a bit more so you guys can see. So like before, you can see here that it's got the schema. It's then asking you for a bunch of parameters that are there. So here's my parameter section right here. Parameter section is asking for admin name, admin password, DNS name, that sort of stuff. Scrolls down, you've got levels and that sort of stuff. So he's got some pretty good ideas on how this is all deployed and everything else there. What I wanted to do is scroll you all the way down to the bottom here. So bear with me and take you all the way down to the bottom. Because I wanted to show you this, is that at the very end of this deployment, when it's all done and it's all deployed, the neat thing that this guy does is it's going to go off here and actually run an extension to be able to run a new script inside of this Linux box, because it's running on top of Ubuntu. And it's going to go ahead and get a version of this script here. In this case, it's from the GitHub location for where this file is located. And it's got the actual shell script that would go ahead and do the download of the most recent version of the Minecraft server, install it on the individual box, and then configure it with the parameters that are required to be configured, including the ability to concat a bunch of different information in there, including the Minecraft username, the parameters, et cetera, et cetera, et cetera. So this individual script goes through and kind of shows you in a simple way the deployment and automation of an individual box, lock down the firewall, download and install an additional piece of software, configure that piece of software, and then open that box up to be able to be used as in this case, an application server. It happens to be running Minecraft, to be able to go off and to do that deploy. So those JSON files are available for you to take a look at under what's known as the Azure Quick Start Templates. This is the GitHub view of where this is. You get to this through a web interface for searching that I showed you earlier off of Azure.com website. And then you can find the nice, easy way to be able to search and see what they are. This is the area that you can start to look at how individual JSON files are going to be put together, and also how you can start to understand how JSON files can be used inside of your environment. There's obviously a bunch of different JSON files that in different environments. Let me kind of give you the hint here. 101 is basically your entry-level, simpler task to be able to understand how things do. The 201s, if you scroll down here, 201s get a bit more advanced with what they're doing. So here's some load balancers. Here's some text message alerts with logic apps and that sort of stuff. Here's a content delivery network with storage account configurations. They get more advanced. Then they get into 301s, which also get more advanced than the 201s, obviously, from a complexity perspective. So we're talking about multi-VM templates. So here's a multi-VM scale set Linux deployment as an example. Kind of cool stuff. And then you have what I call the free-for-all. And these free-for-alls are people that have contributed to the individual Quick Start community, because anyone can contribute to the Quick Start template community for things that they find interesting that they want to go off and share with that community. We've got over 270 different contributors into this particular Quick Start environment. And again, each one of them have a different varying level of good or bad documentation about how these individual ones work. But we do try to curate them, we make sure that they're working, and then also help you understand how they work too. My suggestion to you is start off with some of the 101s that make sense. Like as an example, really simple, Here is a 101 VM simple Linux deployment. So this is a very simple template to go off and deploy a single Linux VM inside of your Azure subscription. Not a Linux person? Well, here's the 101 VM simple Windows deployment inside of your environment. Very simple to do. Here's another one over here. Windows VM multiple data disk deployment. So if you want to get more IOPS, you can use this one here to deploy multiple data disks at the same time to your infrastructure and to your environment. So different things you can go to and try to progress through where they are. Another resource to get you started with this is also inside of the documentation tab. I showed you the resources for the quick starts. Over here under compute and under virtual machines, there is a bunch of different information that's out there to get you started and how to get it up and working within the Azure environment. Some good videos that people have done. There's a video that Mark did that I helped produce for Azure Scale Sets that's out there. How to go ahead and upload a Red Hat image to your environment. And then obviously some news that's on there. But on the left-hand side, you're going to see a bunch of different links to how things work, how to get started with Windows, things you should do. Here's a learning path for getting started with understanding how Windows VMs work, how to create a VM through PowerShell, how to create a VM through the portal, and that sort of stuff. And then it gets gradually more and more complex that's out there. Browse around the documentation site. On Monday, after the events on Monday afternoon, I managed to grab a couple of pints with Mary Jo and also with Paul. And they were saying that they literally just discovered this documentation area and some of the walkthroughs that are available inside of it as a good resource to point people to. And I can tell you, actually, one of my current jobs that I'm doing inside the compute team is revamping this particular documentation page to make it even more useful to you. And so if you have some recommendations about what I can do to improve the documentation on Azure Compute to make it more relevant for you, by all means, send me a tweet to @RicksterCDN, and I'll get back to you because I want to know what we can do to make it better. The stuff that I've been working on so far isn't going to be available to be viewed in the not too distant future, but soon, and I'll talk about it with a blog post, you'll be able to see all the goodness that we have planned for making this documentation section even better inside of your environment. Now, I thought I would at least show you a little bit about what's going on inside of our environment. And so this is something that you end up getting used to understanding how this works in the modern world of working in the operations space. This is something that is known as Git Bash, the command line version of working with the Git source repository up on GitHub. I showed you the website that we were working with before, right here, and the ability to find the resources for the quick start templates as well. This resource templates, as I mentioned, they all reside inside of GitHub. So I showed you the link to a particular quick start templates. There we go right there. This is inside of a website called GitHub. If you're an IT pro and you haven't started to work with GitHub and the Git environments at all, you're going to want to start to try to brush up on some of this because it comes in quite useful. So I happen to have been mentored and taught a bunch of stuff to get me up and working inside the Git environment with my new job that I've got going on. So I thought I would just show you what I've done is I've gone ahead and I've cloned a copy of the entire quick start environment down to my local box to be able to use and to work with. So I have a local copy of all these different templates that are already brought down. And the Git environment, I happen to use Visual Studio Code, not the full version of Visual Studio, Visual Studio Code to go off and to make changes and maintain and do stuff inside of my JSON file and my JSON templates. So if I was just to go ahead in here and say file open, I got a recent one that's in here, double check, where is one that I had here? Let's go and open file. There we go, Simple Windows is already open. This is the one that actually is a JSON file I want to go off and modify. Make it nice and large so you guys can see. So this is the Quick Start Template 101, making a simple Windows VM. Quite simply put, as you saw before, I got my parameters area. I then have all the stuff I'm going to be asking for you if I wanted to go off and do a deployment of an admin username and password, DNS label, how that works, OS version for what OS I'm going to be running. Notice these different values that are drop-down boxes. These are my variables that are there, so I can see what I'm going to call my data disk that I'm going to be running this guy off of, my network card name I want to use, my VM name that I'm using. So here I can go off and change this to Rick's VM if I wanted to. It's currently a standard D1 from a deployment perspective, from a VM size of the machine. I can go off and change that to a D14 if I wanted to get some more horsepower. And then again, I can go off and make more change to this environment if I wanted to. But if I go in and hit save, that guy now is saved. Inside my Git environment, if I change back into my Azure Quick Start templates, into my 101 VM Windows, is it Windows? dir 101 VM. There we go. I want to say change into my 101 VM simple Windows environment. Inside there, I made a change to that file. I can say git status. You can see here that that one file I made a change to on my local box. I'm able to go ahead and now say git add to add the changes on an individual file onto my local repository so I can track them. Azure deploy.json file. I can then say git status to see what's up. Now I know the file's been modified from the original because Git does a tracking system. Now I can say git commit, put in a comment, and I'm going to say made a change to VM name and size. There we go. It's now been changed. There's been one file change, 2 insertions, and 2 deletions. And now I just do a git push up to Rixter CDN. And off it does. Now, I see that I got a couple of minutes left. I am going to be taking some questions, I think. I'm taking questions, aren't I? Do you know if I'm taking questions? Yeah, I'm taking questions coming up. So, wrapping this up, things to pay attention to, quite simply put, Azure IaaS, Azure environment is going to be your easiest jumping in point to understand what's going on inside of the cloud space that is the most relevant to you as an infrastructure professional, as an IT pro. Things you're going to want to pay attention to more so now that things have been progressing are things like Azure Virtual Machines and Azure Virtual Machines, how they work and how they're deployed using ARM templates. Just to kind of give a little bit of a hint, in case you haven't already been told by Woolsey in the beginning, these Azure Resource Manager templates, this concept of how this works, will be working the same way inside of your Azure environment as they are inside of your on-premises environment as well, using the Azure Stack. So take some time to bone up on what's going on inside of these concepts of ARM templates and how they work. Easy way to do it if you don't have the ability to deploy an Azure Stack is to go ahead and sign up for a trial at azure.com and then go and try some quick start deployments. Don't worry, documentation is getting better. We're getting better at making it so you understand how these work, what you can do with them, and how you can deploy them. That template that I just pushed up to my environment, I can actually deploy directly from my GitHub account into my Azure subscription and then see how that worked if I wanted to, but I'm running out of time. So my suggestion to you, besides just going off and basically looking at Azure templates, the ARM environment, and how that works, is really jump in. Go ahead and get started with what's going on inside of Azure, because it's definitely the way of the future. If you remember from the discussion with Jeffrey Stover on day one, he was talking about core competencies that you need to be concerned about inside your environment, and also additional ones that really are not as important. Those additional ones, you don't really want to focus too much time and effort on. Focus on those core ones. Cloud environments, infrastructure as code, JSON files, ARM templates, and ARM as far as a way to go off and deploy inside of Azure and inside of your Azure Stack or the Azure Cloud is definitely some skills that you want to go off and to invest in. I've already given you these resources before, and you've probably seen this slide a million times. MicrosoftVirtualAcademy.com has got some great stuff that's out there on Azure Resource Manager and Azure Resource Templates. Likewise as well, hit me up on the Twitters if you wanted to on @RixterCDN. You can also go ahead and see some great stuff also here on Channel 9 for the rest of this week that's been going on for channel9msdn.com. Thank you to all of our partners, IT Dev Connections, Thurrott.com, and Petri.com as well. You guys are doing an awesome job streaming. And you know what? I think I'm out of here. Am I done? I think I'm done, right? Yeah, I'm good. Let's go off and take some questions, see what's going on. Cheers.
Nice one, Mr. Claus.
This is the secret behind the scenes. You haven't seen this before. So there's actually like 4 or 5 different people trying to make sure that I don't trip. And here we go. And oh, look out! Jeez, they're shooting me with like Nerf guns and everything else, multiple shots, and we're going into the secret broom closet.
You're talking over my intro. I was supposed to give you a fantastic intro.
Hey, they left my mic on. I couldn't do anything about it.
Hello, welcome, sir.
Hey, man, is this like the Azure Groove Room?
This is where this is where the real
I'm waiting for like
comes out.
the dance music to start with this funky light system we got going on, man.
We've got all the moves.
You got it, man.
Yeah.
I feel like I'm also on like a high chair.
Or a low chair.
Low chair. There we go. I think it's sinks or something.
It's based on weight.
Oh, nice. Oh, thank you.
I'm only joking.
Thank you a lot.
You're looking fly.
Nice to see you on-premises, guy.
It's good to see you. Infrastructure in Azure guy.
You got it.
We are hybrid between us.
Oh, look at that.
Yeah. If you don't know, if you've not been following the Ops team, which is a very popular Channel 9 show, I think it's the most popular on the whole of Channel 9.
Oh, yeah. Good homepage placement.
Yeah. Rick's a member of the Ops team, recently left our technical evangelist team to go to engineering. I saw the shameless plug of Azure documentation in the session there.
Hey, that's because I'm working on that right now.
Yeah, but it's good stuff, and it was a massive loss for the team, for Rick to move on, but we're glad that he's using his Azure powers in documentation to help you guys learn. But there's been plenty of questions after we've just been Nerf gunned.
I know, eh?
It's looking at the helmet. I wore this in honor of you. We
nice.
found it in there, and apparently it's been dug out of the trash, so who knows what.
Some hobo is now hatless, is what you're saying.
Well, I don't know. Lots of good questions have come in from people who've been watching.
You know, you're supposed to be prompting those through to me, and I could have answered them on the spot.
You had so much content, though. We have so much content that we wanted to make sure you got through, so we'd have stuff to talk. If you answered all the questions, we'd be sat here talking awkwardly about hats.
There we go. That could work.
Exactly.
What's up, man? What are the questions? What are going on?
A question from Bob. How do you use Azure day to day?
How do I use it day to day?
I presume it was you and not generically you.
Okay.
You use Azure.
Well, if it's me,
yeah.
being you, me, the royal we, I guess it is.
If you like.
Basically, I have a couple of different Azure subscriptions. One's my MSDN one, which I use for my learning. I've got a production one that I have for responsibilities inside the engineering team. I have one I have access to, which is actually images for image deployment across all of our data centers and stuff like that. And I've been given different rights and roles and responsibilities in those more production ones, obviously, because there's very secure stuff that's in there.
G-Series.
Despite what some people might think, none of us have access to the stuff that our customers are deployed, because that's all secure and it's all theirs, and obviously it's all stuff that's going on. But the background infrastructure and stuff like that. And I have to go off and use tooling to actually go off and touch and use any of those things. So there's like a layer that basically prevents me from doing anything inside of a production environment, thankfully. But I use it from a perspective of building infrastructure for demos currently, or customer proof of concepts. And so I'll get asked to come in and to talk to a customer X, who actually is doing some digital encoding of files. And so they want to look at moving their on-premises data center, 400 machines, over and into an Azure environment. We can mock up an example of, here's the workflow of what they do right now, the custom apps they've built that basically takes in video files, converts them into different formats, and then chunks them up and does different things, and then uploads them to different customers and sort of stuff, puts on subtitles and stuff like that. That whole process we can mock up inside of an Azure subscription to see how it works. And so we'll spin up a subscription, do the proof of concept stuff inside of that, and then build the architecture in the JSON file, and then deploy it and test, deploy, test, and iterate to see how it works. So basically lots of proof of concepts.
Now we'll come back to JSON files. I saw you, I name dropped, I heard my name. Did you mention Matt and JSON files? I am not struggling with JSON files.
Nice.
They're very easy.
Good to see you progressed out of the 101s now.
I'm struggling. What are the first, following on from that, how you use it for day to day, what are the first typical use cases people typically take that you've seen when moving to Azure? What are some of those low-hanging fruit, I suppose you would say? It's kind of like when we go back to virtualization. What's the first things you shift to virtualization?
Low-hanging fruit to get started. Well, a lot of times what I see is obviously things that are like ancillary services that you can use. If you have Office 365, as an example, you're using Azure Active Directory already for Office 365. You're doing some level of synchronization. If you're doing Windows Intune or device management with enterprise device management stuff, you're going to be using portions of Azure that's in there already. So you're already starting to use Azure right now. That's one way to start doing stuff.
Yeah.
Then you're able to go in and to provision off of that Azure subscription individual resource groups. You can then go off and start the different projects. Some of the stuff that I see that are actually really interesting, I think Woolsey talked about this at the very beginning, was Azure Site Recovery. Being able to use it to coordinate disaster recovery fallback between two different data centers that you own, or one that you own and one that we own inside of our Azure environment. So ASR is one thing that a lot of customers are actually finding quite helpful.
And Azure Backup as well.
Azure Backup also stores up there as well. Azure Azure Backup Server, which also works as
Yeah.
well, to be able to go off and to basically do DPM-like functionality,
Yeah.
to be able to go off and have offsite storage up inside of your Azure storage account. Storage is dirt cheap inside the cloud, dirt cheap. Plus it's replicated 3 locations inside the same data center, protected against loss. You can set up a storage retention policy and stuff like that too. And then what I see is a lot of people going off and just trying to understand how Azure's working as an IT pro perspective,
Yeah.
and they'll go off and make a resource group, put in some networks, put in some network security groups, put in some virtual machines, try to build some sample stuff and see how that works, how they can secure it, how can they manage it. They're using the same tools they'd be using anyway.
Yeah.
Using PowerShell, System Center if they wanted to be able to do stuff, and they're using, if they wanted to, again, Linux and Azure CLI and that sort of stuff as well.
Yeah.
I've actually been brushing up a lot of my Linux skills recently because I've been working as part of the Linux team,
Yeah.
and so I've been using an Ubuntu image. It's virtualized on my Hyper-V client on a Windows box.
Nice.
But I'm using an Ubuntu machine with the Azure CLI on the Ubuntu box to be able to manage and work with my subscription to try to cut my teeth on how the Azure CLI works as opposed to using the PowerShell world.
So you know you get from your bash now.
I do know Git Bash
Nice. Excellent.
to be able to work with it. And if you are looking to understand how Git works, get out of the GUI.
I see what you did there.
There you go, got it, eh?
Wow. Was here all week.
I personally find I understood it a lot better when I went down and installed a Git Bash client from github.com on my local box, and then went back to my Unix Linux days of understanding the ls commands and doing cron jobs and doing editors and that sort of stuff. But I use Visual Studio Code because that works on my Mac, works on my Linux box, works on my Windows box, and it's all the same. So it doesn't matter which box I'm on, I always know the interface.
Nice.
I don't want to have to learn different editors. And trust me, I don't want to go and install, how big is install a Visual Studio? How big is that?
You're asking the wrong person.
40 gigs,
There's
50
no nano
gigs?
server.
There's no nano server version of Visual Studio.
It isn't, it's a lot bigger.
But you can run Visual Studio Code. And actually, I tweeted this out just last week. There's actually a Azure Resource Manager tools. I was going to show that. I forgot to show it. An Azure Resource Manager tool plugin just for Visual Studio Code that just came out like last week.
Nice.
Which gives you the parameters, the syntax, and different flow, and that sort of stuff, and IntelliSense type stuff inside of your templates. They're
Cool.
for JSON templates.
So one takeaway that I took from that, there was lots more, but one key one is you learn so much more when you actually have a go with it.
Oh,
Rather
yeah.
than just reading or
Jump in.
watching videos are great to get you excited and help you understand why and what's important and perhaps show you how some of it works. But there's nothing better from a learning perspective for new IT pros that are new to some of these technologies. Just get on board, get a trial, try it out, play with it on your own machine or servers if you've got available.
Yep.
Now you mentioned resource groups in that last comment. Can resource groups be nested is a question from Aiden. There's a follow-up. So, for example, one resource group containing all web servers, which is in the larger app resource group, kind of like a folder directory mentality. And if yes...
Is this Aiden Finn from the...
No, Adin. I might be pronouncing it wrong.
Okay.
A-D-I-N. Adin.
You should know this if it's Aiden
And if
out of Ireland.
Can RBAC be inherited, overwritten, similar to GPOs? And
Okay.
OUs? That's a really long question.
It's a very long question, very easy answer. No, they cannot be nested.
Right.
But the stuff inside of them inherit from the group. So you can set a base set of RBAC principles of ideas for Matt can edit the following objects, whereas Susie can only read access stuff and Rick is denied access stuff. You can set that at the highest level. Very good, isn't it? And that flows down to all the resources inside the group. And then inside that group for a VM or for a network configuration or for a NIC card, you can then go and further specify a local instance which will override whatever was done at the higher level.
Right.
So I've been added
granular
into
control.
people's subscriptions for projects and then only been able to access one of the resource groups that are out there.
Right.
If you're going to do what you want to do, you really would have one resource group for the web front end, one resource group for the databases, one resource group for the back-end databases, and that sort of stuff. And they all reside inside of your subscription, and they all reside inside of one data center.
So the subscription becomes the high-level group
Yeah.
in essence. Okay, so sticking with IT pros embracing the cloud, some of these new, more, at least on the surface, dev-oriented concepts, ARM templates being one, which obviously I struggle with, JSON. What are your suggestions for a traditional IT professional around learning ARM templates? Is it best to just let the devs create them and IT pros manage the fabric? Obviously, you don't manage the fabric in Azure, but manage the boundaries for the devs, and Azure Stack this applies for as well.
See, I would strongly recommend you don't just let another group do it. Jump in. become involved in what's going on.
JSONs don't have to start, or
No,
JSON
no.
files don't have to start complex. They can be complex. They
Yeah,
can do a lot of things.
start off simple with them, but really the JSON template starts on a whiteboard and starts with a discussion of the architects of the solution getting together with the infrastructure folks and understanding what you want to go off and deploy, what machines you have to have doing what types of roles, who's responsible for those machines, how do these machines talk to these other machines inside of your environment, what's your and then back to traditional IT pro stuff, what IP address are you going to use, what rules are you going to have for different ports talking to these different machines, what operating system is going to be running on those different types of boxes. That's the concrete stuff that all of us have right now. We just have to learn the difference of how you manage them inside of a cloud environment, inside of Azure. And so definitely get involved with it. Take your hand at how they work. I will say Visual Studio has some very nice plugins to be able to go off and to create these ARM templates. And I just suggest collaboratively working with a team of your devs to figure out what it is they're building and how they're building it, because it's not always logical for how these things go together. The tools make it better.
Right.
We're making the tooling better, both inside Visual Studio and outside of Visual Studio to be able to do stuff. I seem to remember we released the ability to go through and to export an ARM template once it's been deployed to be able to take a look at it. So
Once you've
basically
gone
you
through a
build it,
provisioning process,
you build it, it's probably been provisioned, you can export it and get a version of what's there as like a starting point.
Right.
But it's going to get better. And basically we're not necessarily drawing a line in the sand, but we're saying, hey, this is a great way to do this because it is a templated way of having your base infrastructure. Now don't think that means you throw out all the stuff you're learning with PowerShell or all the stuff you're learning with scripting, because you define your infrastructure inside of the JSON template, but all the configuration after the template's been deployed has to still take place. And so to eliminate human error, you script that with PowerShell, you script that with a Chef client, you script that with a Puppet implementation to be able to go off and to define configurations for those different boxes, install the bits for SQL, install the configuration for SQL, or maybe you're running MySQL and you want to have that optimized or whatever. You still have to do all those individual configurations. How you choose to do that is, again, your existing skills. And then you iterate and try different versions of this with your different versions of the JSON file. So that's where source control comes into play. That's the area that probably took me the biggest part of learning. Trust me, it took me a while to figure out Git, and I still have not figured it out because it is just foreign to me because I've never really had to manage source control before. And it is a pretty good source control management solution for sure. And I'm now actually using it for things like my PowerShell scripts.
Nice.
I'll put my PowerShell scripts up inside of my GitHub repository, and then I can go off and make changes to them. I check them back into Git. And other people have forked my repository to be able to go off and use my scripts.
Sounds
In
painful.
fact, Virtual PC guy,
Right.
Ben Armstrong, has his team's whole section of Hyper-V stuff, PowerShell scripts,
All the
and stuff like that,
documentation is up there,
all's
yeah.
up inside of Git to be able to get community contributions and also versioning and also editing and
Samples
fixes
all
as well,
sorts, yeah. It's
and
really
samples,
good.
stuff like that
It's a
too.
really good use of it, and means the content development is very agile.
Yes,
So
to use more dev terms.
absolutely, I didn't even know I was doing it. It just came out.
I know.
Next,
we're
I'll be saying DevOps
ops dev,
next, yeah.
very ops dev in here.
Are there any GUI tools that are going to be made available for creating, editing ARM templates? Just to wrap up the ARM stuff.
Currently, it's Visual Studio. We just released Visual Studio tooling for Visual Studio Code, and we're committed to making the experience better. Is the best that I can say. As I mentioned, you can go ahead and make your infrastructure piece by piece inside of the Azure portal, inside of your resource group, and you are able to go in and choose different options of being able to potentially export that to be able to take a look at it. But really, you start off working with just Azure.com resources and quick start templates to be able to find some sample templates to work with. And there's rumors that some of those sample templates are available and are going to be used in testing to be able to go off and deploy stuff against the Azure Stack. The Azure Stack's coming up next.
Azure
isn't it?
Stack is next. Yeah, the next session. Great segue. We've got some stuff to talk about before that. But
Oh,
yeah,
okay,
Azure Stack is
yeah.
the big on-premises.
It's the same resource manager code and infrastructure being used to deploy on top of Azure Stack.
Cool. Well, thank you very much, Rick, for answering our questions. Sorry we didn't get to all of them. We want to make sure that we give a minute to get your feedback. I know you've been sending it in during the day using hashtag TechNet VC, but there's some specifics that we want from you. We want your feedback. How satisfied are you with the the overall event across the 3 days. Remember, this is all available on Twitter. You should be able to find these. How satisfied are you with the content that's been presented? And as a result of TechNet VC, how likely are you to recommend Microsoft products or solutions to colleagues or peers? So loads of good stuff there. So please give us your feedback. Check out Twitter. We want to hear from you. What's good, what's bad, how we can improve, and what we want, or what you want for the future going forward. Now, to finalize, to finish up for the next and final session, Azure onto Azure Stack is a perfect segue because it is Azure in your data center. And to help us with that, we've got Mr. Charles Joy, who's going to take us through Azure Stack. He's been instrumental in the development of Azure Stack so far.
Oh.
We didn't give him a crazy photo.
Oh, nice.
But we've got a question
photo.
for you as well.
What?
What?
Crazy photo?
Yeah, you had a crazy photo on yours. Did you not see it?
Oh, I didn't see that.
Oh dear. So watch the recap, which is available on demand. You'll find very soon. What is the most effective channel to send your feedback for Azure Stack? And we are in a stage in development now with Azure Stack. We're only at the first technical preview where we can get your feedback. So what is the most effective channel to send your feedback for Azure Stack? Let us know and enjoy the session. Thanks, Rick.